4.5 says quadratic equations. And at this point, you should be saying, well, so is everything else in chapter 4. It's all quadratics. It is. So what is up with these quadratics? Why do we spend so much time on them? Because there are so many things that we can find with quadratics. We already know we can graph them. You know, and if they give them to us in vertex form, it goes really quick. If they give it to us in standard form, we do a little work, but we can get it. You know, it doesn't take forever. And then we found out with these quadratics, some of them are factorable. So if we factor them, what we're really trying to do is find another piece of the puzzle about quadratics, because here's the thing. We hate tables. I mean, we all do. You know, it's one of those things where you say, why do I have to put a number in here to get, isn't there another way for me to get some nice numbers just by looking at the thing so I don't necessarily have to make a table? Well, we already know where the vertex is. We already know if we plop a 0 in there, we're going to get the y-intercept. So what about the x-axis? I mean, if we could find a couple of really nice points on the x-axis, then we probably wouldn't need a table at all. Well, for some of them, it works out really nice. And we can find the x-intercepts, and that's going to be those that are factorable. We already know that some of them are not factorable, and in real life, hardly any of them are factorable. You know, in real life, things just don't work out all nice and perfect all the time. So we're going to do this two ways today. First, we're going to look at the factorable ones, the nice ones, and then we're going to grab some graphing calculators and find the ones that maybe don't work out quite so nice. And in the end, I'm going to teach you how to educate a cheat on factoring. If factoring just has not come to you, my gosh, you've been through it twice already. You've gone through exponential algebra, you've gone through algebra 2, and we have factored like crazy, and it's still not working for you. We'll use our graphing calculator to work backwards and factor. And that way everybody should be able to do it. So no giving up, and make sure you're paying attention today to what's going on up here, not watching the completed notes that you see on your Chromebook. So make sure the Chromebook is closed up. The more you participate, the more you remember, all right? So quadratic equations right here, and our objective is up top, but it says solve quadratic equations by factoring. That's not what you said, Cedarholm. You said we're going to find the x-intercepts. That is solving. The thing is, there are lots of synonymous names for what we're going to do. It's solving, it's finding the zeros, it's finding the x-intercepts. They all mean exactly the same thing. It's just that if we're talking about a graph, we refer to it as the x-intercepts. If it says solve, we're finding zeros. So lots of different things. So with this one, we can do what I was just talking about. We know where this is. We're going to be able to find that. We will know where that's located at. And then we had to make a table so we could find other stuff. I want to make a table. You know, it'd be really cool if I could find these very easily by factoring, and then I've got my graph. You know, I don't need to make a table to find any more points. So how do we get those? Well, we get those by using a little thing called the zero product property. Here's what the zero product property says. It's got a big long name for something very basic. If you multiply two things together and you get 0, one of them had to be 0. Makes perfect sense. I tell you my number's 3, and I want you to multiply it by something to get it to be 0. You have to say, my number is 0. Have to. So that's what the zero product property says. If A times B, where A and B are two different numbers, comes out to be 0, when you multiply that together, one of them had to be 0. Had to be. Makes perfect sense. So we use that to realize, hey, if we're graphing, and we're graphing these 2 points, that's going to be something 0 for the coordinates. So we want y to be 0. That's why it's called finding the zeros or solving. So we're going to solve a quadratic equation by factoring. We're actually going to solve quite a few by graphing today. And I want you to remember this, because this happens every time when we take this test. There are going to be problems on the test where it says factor. All you do is stop, like we did on the worksheet. You're done when you're done. Now, the reason for that is because we don't have equals to something. You know, if they just give us this, we factor it. There's no way to solve that. There's no what does it equal, you know. But There will also be a section of the test where it says solve. So sometimes what happens is students stop when they have it factored and they're like, oh, I'm done. But not if it says equals 0, we have to keep going. So what you see here is that this started off as x squared minus 5x equals negative 6. And somebody said, hey, if I'm supposed to find the zeros, doesn't there have to be a 0 up there somewhere? They're absolutely right. There has to be a 0. So what they did was they said, I'm going to move that 6 over, so I can have a 0. So that'll be x squared minus 5x plus 6 equals 0. Close that Chromebook. So x squared minus 5x plus 6 equals 0. I hope that's factorable. Well, there's nothing I can pull out of all of these. This is not a perfect square, but maybe, just maybe, I can come up with two numbers that multiply to positive 6, but add to negative 5. Can you think of a couple? Negative 2 and negative 3. Now here's what we're saying. If this times this equals 0, either this has to equal 0, or this has to equal 0. Has to. That's the only way this is going to happen. There's no other number that you can multiply something by and get 0 other than 0. Well, that's just a quick little one-step algebra there. We're going to add 2 on this one and get x equals 2. So there's one solution. And we're going to add 3 on this one and say x equals 3. How? You cannot. And here's why. If you multiply, we want this positive 6 right here. If we multiply 1 and 6, or 6 and 1 together, we will get the 6. But there's no way that's going to multiply to, sorry, I keep saying multiply. Add to a negative 5 in the middle. And that's because they would either both have to be positive or both be negative in order to multiply to 6. So, yeah, we've got to be careful about getting the right numbers there. Now, I want to know, does this make sense? You know, I don't just want to do the math and go, oh, I did the algebra, I'm done. Well, if I put a 2 in here, won't 2 minus 2 give me 0? Yeah. So I'll be multiplying by 0. And if I put a 3 in here, 3 minus 3 would give me 0. I'll be multiplying by 0. So some people don't even have to do these steps. They just look up here and say, oh, it'd be 2 and 3. Boom, I'm done. You know? But the steps are great on a test, just in case you mess up. So we've got x equals 2 and x equals 3, and we're wondering, did we do this right? Because this is a test, we want the points. Well, remember, they have to work in the original. So we can plug those back in and make sure that x squared minus 5x really equals negative 6. And it has to work for both of them, not just one. So if we put a 2 in here, this is going to say 2 squared minus 5 times 2 equals negative 6. 4 minus 10 equals negative 6. Yeah, it does. So the 2 is good. It works. And then we've got a 3 here. So 3 squared minus 5 times 3, does that also happen to be negative 6? 9 minus 15 is negative 6. Well, yeah, last time I checked. It's negative 6. So they're both good. Now, you might say to yourself, Cedarholm, I'd rather check them in here. You know, I'd much rather check them in here and make sure they get a 0. One teeny little chance that you might be wrong at that point, because you might have accidentally done the wrong thing to get this negative 6 over to the other side. So it's always safer to go all the way back up to the very beginning and plug them in and see if you got it right. All right. Nothing new here. I mean, this is factoring. We've been doing that. And using algebra to find zeros. We've been doing that. So I'm going to do a whole lot of calling on people today. I'd rather not do the calling on people, but how you're going to avoid that is when I ask a question, everybody's going to tell me the answer. Because here's the deal. If you just sit out there and vegetate and write down everything that I say, you're going to remember about 15% of what we go over today. But if you participate and you're talking and you're thinking, you're going to remember about 85%. of what we do today. So hang in there with us. X squared minus 7x equals negative 12. Is that ready for factoring? What's wrong with it? Gotta have a 0. Let's add the 12. All right. You see any numbers we can pull out of all of that? Okay, is that a perfect square trinomial? No, 12 is not a perfect square. Well, it's possible that it's still factorable because we know x times x will give us x squared. Well, let's think about it for a second. We're going to need a couple numbers that multiply to 12 and add to negative 7. Negative 3 and negative 4. There they are. And then we continue on because this is supposed to equal 0. And on the test, we're going to write down x minus 3 equals 0, add 3 to both sides. X equals 3, but thinking all along, of course it equals 3 because 3 minus 3 would be 0. X minus 4 equals 0, add the 4 both sides. X equals 4. Of course it does because 4 minus 4 would be 0. Makes perfect sense. And you could check them. But you guys know how to check already. So, hey, look at this weird one. Should we just start factoring that one? It's got a 0, right? We have something we could pull out of this one? What do we take? X. What would be left? Whoa, that's a little weird. Wherever there's an x, there is an answer. Wherever there's an x, there is an answer. Take a look at that. If that front x is 0, do you agree with me that it doesn't matter what they have in the parentheses, we're going to get 0 when we multiply that together? Absolutely. So there is an answer there. And this one we just did on the last problem. So we're still solving by factoring. It's just this time we factored out a common monomial factor. We do 2 sets of parentheses business. All right. This one looks a little challenging. Is there something we could pull out of both of those terms? No. Would we want? Yeah, somebody just said they're perfect squares. We wouldn't want to. So how do we factor that? How do you make it so there's no middle term? Anybody remember? Now some people will look at that and they'll be able to say, hey, x equals 5 halves and x equals negative 5 halves. But for most of us, it's going to take at least this first step here to go, oh yeah, I'll have to subtract 5 and then divide by 2. And on a test, we should never try and do all that in our noggin anyway. We should always be showing all the work. So then with the 2x minus 5 equals 0, we would add 5 to both sides and divide by 2. And there they are. Again, we'll check them. 6x squared minus 19x minus 7 equals 0. I am not liking the looks of that. First of all, is it ready to factor? Do we have anything we could pull out of all those numbers? That is really disappointing because that's 6. That is not fun. Because this is one of those where we go, oh gosh, I got 1 and 6, 6 and 1, 2 and 3, 3 and 2. Well, I guess it wasn't that bad. We only had 4 of them. And in the back, are there lots of numbers that multiply to negative 7? Not lots. Now we need outside times outside plus inside times inside to give us negative 19. Start looking. Let me know when you found it. Siri, you find it already? Where is it? Right there? Okay, so Siri says 3 times negative 7 is negative 21. 2 times 1 is 2. Negative 21 plus 2 is negative 19. There it is, the bottom one. Remember, they always try to pull that on us. So now, the order is really, really important. This is in the front. This is in the front. This is in the back. This is in the back. And in that order. And then we remember, while that was tons of fun to do that factoring, we are not done because we still need to find the zeros. So we subtract 1. And we divide by 3. And get x equals negative 1/3. And then when 2x minus 7 equals 0, we would add a little 7 action to both sides. And divide by a little 2, and x would equal 7. And again, it's checkable. And with this one especially, you know, if you're unsure about whether or not you put the first ones in the right spot and the last ones in the right spot, put them back in, let the calculator tell you whether or not it's going to work or not. All right, next one up. 2x squared minus 72 equals 0. Well, it equals 0. That's good. Got something we can take out of there? Oh, yeah, we do. What are we taking? Taking a 2. Ooh, I think what we see in the parentheses there now is supposed to be something really quick and easy to factor. Why? Perfect squares. Yeah. So, what are we going to need? X plus 6 and x minus 6, exactly. Have to have those opposite signs to get rid of that middle term. There isn't a middle term. If you're saying, see, Jerome, you've said this middle term thing like 5 times, I don't have a clue what you're talking about, middle term. Remember, the first one has an x squared in it. The second one would have an x in it. There's no x here. If there's no x here, there's no middle term. The only way that happens is opposites. FOIL. Outside times outside, inside times inside. Is this an answer? Is there an x there? Then we could care less about that too. That is not our answer. Our answers come from these two right here, because that's where the x's are. Wherever there's an x, there is an answer. We're going to subtract 6 from both sides and get negative 6, and add 6 to both sides, and x equals positive 6, which again, we just could have looked up here and said, yeah, negative 6 and 6. That's going to be x squared plus 11x equals 26. Start factoring. Got to move that 26 over. Anything we can pull out of all of that? Is that a perfect square something or other? 26 isn't a perfect square, is it? Okay, so good old-fashioned factoring. 2 numbers that multiply to negative 26 and add to 11. Heard a couple people say it. What are they? Yep, negative 2 and positive 13. Multiplies to negative 26, adds to 11. Again, you know, because it's a test, we would write down this, add the 2. I know. So here's the deal. If you are solid in this, I mean, if you're thinking, I got this factoring down, when I asked you earlier, you were a 4. You could teach factoring to somebody else. Am I going to take off points if you go from here to x equals 2 and x equals negative 13? No, I will not. No, I will not. But you better be sure you're right, because remember, these steps are worth points. So if you're wrong, and I don't see this, you're going to lose more points than you would if I had seen those steps. So just keep that in mind when you're working on the test. Alrighty. 4x squared plus 12x plus 6 equals 0. Is there something we can pull out all that? There is. A 2. Every little bit helps. Still not perfect squares though. Okay. Well, the good news is it's smaller numbers, so it won't take us too long to find them. In the back, numbers that multiply to 3, hey, that's just 1 and 3. Find it. Let me know when you found it. Which combo gives us what we need? Keep looking, there's not a lot to check there. Is it there? It's not. Now what do we do? Oh, you guys are thinking, I'm crazy, I'm not finding this. What's going on? It happens. And remember, I warned you, real world, things aren't always factorable. So with this one, we're going to have to say we can't factor it to solve. No, it doesn't mean we can't solve it. It just means we can't factor it to solve. There's always that wonderful quadratic formula thing, you know.
How often does that happen?
In this book, almost never. This book is really good at giving you problems that are, you know, truly factorable. But when you get to the word problems and there's all kinds of decimals and that kind of junk, then yeah, we're going to learn to use our calculator when this happens. So this one can't factor be. Doesn't mean it can't be solved. It can. It's just that we can't factor it to solve, and that's what we're doing right now. So let's move on. Something looks wrong with that next one. Yeah, it doesn't have a 0. So some people would say, hey, let's move that 9x squared over, but what's going to happen if I do that? I got a negative first term, so I'm not going to do that. I'm going to add the 48x and add the 64 to both sides. Now, I already heard somebody saying it's a perfect square. You're absolutely right, but remember, the first thing to check is always, can we make it smaller? So can we pull something out of that? 3 goes into 9, 3 goes into 48, 3 doesn't go into 64. You know, you do that for a little bit. But yeah, we realize there's nothing else we can take out, so let's check out that perfect square business. We have to check the middle term. What do you do with the 3x and the 8 to make sure this is working? Multiply them and then double it. Yeah, times 2. So is 3x times 8 times 2, is that equal to 48x? That's good news. That means we're just doing one set of parentheses squared. Remember, that's called a perfect square trinomial. So what goes in front? 3x. What goes in back? The 8. And should we use a plus or a minus in there? Yeah, everything up here is plus. So then we do 3x plus 8 equals 0, and we subtract 8 from both sides, and we divide by 3. So x equals negative 8/3, and then a light bulb flashes and we go, wait a minute, we got 2 answers for all the other ones. Aren't these always supposed to have 2 answers? The answer is, they are supposed to have 2 answers. Here's how we know. Notice how on all of these, come on, smartboard, behave. X squared, x squared. X squared, x squared. So the power of the highest power variable is supposed to tell us how many answers we have. Well, this is a good time for us to grab a graphing calculator. So those of you that don't have one, come up and see me. Let's get you one. We're going to see why this is happening. Why did we just get one answer? Come on up, grab them.
I'll go grab you. Oh, thanks for that.
Anybody else?
Mine's just dead.
Okay. So here's the deal. We couldn't factor this one to solve, but we just want to check and see, does it have two answers? And to have two answers, it needs to cross the x-axis in two spots. So we're going to go into y equals. And we're going to punch this monster up here at the beginning in. 4x squared plus 12x plus 6. And we're just going to hit zoom 6 and see if it does hit the x-axis twice. So zoom 6. It has two solutions. We couldn't factor solve them, but there they are. Now, in the next group of problems we're going to do, we have to find those. So here's what we do. We look at our graph, and we're going to enlist the help of the Blinkster. Blinky is going to help us out here. Good old Blinky. When we can't find something, there to help us. Now, Blinky's going to ask us some questions. He's going to say, are you on the left side of where this intersects? So the left side of this intersection would be here. And the right side would be here. But here's the thing that messes people up. It's backwards on the other side. On the other side, this is to the left, and this is to the right of the intersection. And that's because, remember, parabolas move like this. So left, right, left, right. Well, let's see. When we have needed the Blinkster before, he's always been under second trace. Oh, look at number 2. Finding the zeros. Number 2. Blinky already has this question for us. He says, is this the left side of that intersection? So I'm going to move Blinky so that he's to the left, using the left arrow, of the intersection with the x-axis. And then I'm going to hit enter. And then Blinky says, now are you on the right side? No, Blinky, but I'll get you there. I'm going to hit my right arrow and put Blinky below the x-axis. The calculator only knows left and right. It doesn't know up and down. We would love it if we had above and below on there, but it doesn't know that. And then I'm going to hit enter to guess. And Blinky says, that's why you couldn't find it. It's not a fun number. It's negative 2.366025. That's why you couldn't factor it. It's obnoxious. And then we go to the other one. So we do the same thing, but backwards. Yeah, exactly. Go back and check that you punched in 4x squared plus 12x plus 6. Is your Blinky taking a vacation?
Movie day?
Oh, no, listen, everybody, you weren't watching which one I did. Shh, hang on just a minute, because here's what some of you just did. You found this one first. You can do that. I always find this one first, so I found that one. That's this one. Now I'm going to go back and find the other one. Yeah, you try to get Blinky as close as you can, left or right. So second trace, hang on a second, and then I'll come and fix whatever everybody else has that's going wrong here. But this time, for this one, you have to be below it to be to the left, and then hit your right arrow until you're above it. And that's where everybody's getting the other number. Go on.
Oh, never mind.
Number 2.
Dude, I don't.
Now you're going to move you over here. Get above it. Press center. Now roll it with right arrow. Always left and right. There you go.
Right in here.
And enter. Enter your guess. One more enter.
Alright.
And there's your answer. Go on, Deb.
I would think you're gonna share with them.
Do you?
So we're going to level the intersection and press enter.
Hello, but go ahead and do it. Go ahead and do it like that.
Yeah.
I didn't have it round, I had it round like that.
Oh, some reason it was doing a different set of actions. Gotta go park it up.
Oh, what happened, dude?
Actually, it's a fictional character.
Yeah, the second result is fictional character. Scroll up.
Here. Left and right arrows. A little more.
Dang.
Yeah, we place this so that you
Oh,
go
oh,
above and
oh, what was that?
then-
Nothing.
Yeah. Took out.
I'm lost. Oh, so you have to go above me and below it.
Oh, thank you. I put my desk on the wrong spot because I was hustling to help people. Thanks, Siri.
Oh my god.
All right, we're going to do a couple more of these, but hang on, all right? There we go. So, that one actually crossed in 2 spots. This one, remember, what we're trying to see is why it looks like it only has one answer. So, let's go ahead and graph our 9x squared plus 48x.
One that was right.
Oh, the second one, I don't know.
Shh. Less talking, more paying attention, otherwise people are going to get lost again. We're punching this one in right now because we want to know why does this one get 2 zeros and why does this one only get 1. So zoom 6. Why do you think it only gets 1? It's bouncing. Yeah, this is not crossing, it's bouncing. Now what happens is we count that as 2 zeros because it's like it hits it and then it bounces off. So this does get to count as 2. This is called a zero multiplicity 2 because it counts as 2 because it's hitting off at that point. That fancy hitting off that it does, remember from geometry, that's called a tangent. So it's tangent at that point, and that's why it counts twice. Now, when I go through this next one of finding the zeros with the graphing calculator, please do exactly what I'm doing up here instead of saying to yourself, I know how to punch this in, I'll get it myself. So we're going to skip this for now, all right? And we're going to go to solve by graphing. All right, even when we're going to use the graphing calculator, we have to have a 0 on one side. So we would subtract this 2, and we would add 2x. And we would get this. Now, in your homework, it's going to have like a little graphing calculator icon, and it'll say, use your graphing calculator to blah, blah, blah. So we're going to use our graphing calculator to find the solutions. So we're going to punch this in, and then I'm going to stop and make sure everybody has it punched in, and nobody's going to work ahead and get lost, all right? So 5x squared plus 32x plus 12. All right, you ready?
Yes.
So here's what we should see when we graph it. We should see an up opening parabola. Let's hit zoom 6 so everybody sees exactly the same thing. Now, pretty obviously we can't see the bottom. We don't need to see the bottom. What we need to see is right here. And we're going to go after this one first. So we're going to get Blinky above the intersection with the x-axis by using our left arrow. And then we're going to hit enter. So second trace, number 2, again, don't try to go ahead. Blinky, look at those numbers right now. Blinky is way down or way up at 5 point blah, blah, blah. And I'm just going to have to keep using my left arrow until I see Blinky coming back up. Now I'm watching the Y's. Do you see how the Y's are way down there at negative 37? So this might take a little while. I'm just going to keep hitting my left arrow. Now Blinky's starting to come back up. Now we can see Blinky. But Blinky has to go to the left of that intersection. Because that's what Blinky's asking us for. Look at his question down there. Left bound. Yes, Blinky. I tell him that by hitting enter. Enter. Now Blinky says right bound. Blinky is waiting for us to move Blinky to the right of that intersection. So hit your right arrow at least once. Hit enter. That'll tell Blinky, yes, now I'm on the right-hand side. Zach, can you help Alex out over there too?
It's gone now.
All right, then you just hit enter again because we don't want to take a guess. We're going to let Blinky tell us where it is. Now look at what Blinky says. Blinky says x equals negative 6, but look at what Blinky says for the y over there. What on earth was Blinky trying to tell us? Blinky is saying this. He's saying, I just did calculus when you hit this button, and I am apologizing like crazy, because I, Blinky, could not find 0. Here's what I found for you. I found 0.0000000001. I'm really sorry it's not 0. That's what Blinky's saying. Blinky, it's okay. That's close enough to 0, Blinky. So he gave us negative 6. Now we need the other one. For the other side, left is below it. So second trace, number 2. And we're going to move Blinky just below the x-axis around the origin over there. And Blinky is way down there at the negative 30s again. All right, now I see Blinky. Now, for me, that's actually too close to the x-axis. I would keep Blinky down here to hit the left. And then right arrow a couple of times. Make sure Blinky is well above the x-axis. Enter. Enter to guess. Yeah, once you get to the below it, for left bound, hit enter. Then go right arrow a couple of times, enter through the right, and then enter. So there's the other one. All right, now I had told you, using this method, we can do an educated cheat. Lucas, put those down and pay attention, please. Here's our educated cheat. If Blinky told us that the answer is negative 6, I want you to think logically. What was in the parentheses if that came out to be the answer? X plus 6. And Blinky said negative 0.4. Well, that's negative 4/10, which reduces to negative 2/5. Now, this is a little harder. How did Blinky get negative 2/5 from a set of parentheses? Well, he must have had to subtract 2 to undo something. That would be undoing plus 2. And if Blinky had to divide by 5, that was because somebody had multiplied by 5. This was really factorable. We could have factored this one to solve. Now, the only time you're not gonna be able to do that is when those decimals come out really badly, like they did on the previous slide here. We had one that just came out nasty. But if you get nice fractions, that means it was factorable all along. Now, what does that mean for those of you that don't know how to factor? If you can learn how to do this, you can use your graphing calculator to cheat on it all the time. Because you can work backwards and put this in. All right,
I like this one.
this one. How are we for time? You're better at finding the zeros now, right? So this won't take as long? Okay. Let's move everything over. Oh my, that's really weird.
Ours is not.
Yours is good?
Ours is 4x squared minus 14x.
Okay, I'll just rewrite it so everybody can see it clearly. So what do we do first? Move them on over. Subtract the 4 and add the x. All right, it's Blinky time. That's right, Blinky. Help us out. Help us out, Blinkster. 4x squared minus 13x plus 3. 6.
Whoa.
You can definitely see the 2 spots where it crosses. So we need to go here for left and here for right in order to get that one. Second trace, number 2. Hey, Blinky's in perfect position this time. Enter. Move him to the right. Enter. Enter through guess. Oh, look at Blinky. He's so proud he got a 0 in the Y this time. Did you do them backwards then, Alex? The left is above it and the right is below it on the left-hand side. Second trace, number 2. Now this time it's the opposite. This is left and this is right. All right, Blinky, that looks like a pretty good spot. Blinky says that was 3. Was this factorable? 0.25. Is that a fraction we're supposed to know? That's 1/4. If you got an error, when you pressed enter, you either weren't above it or below it. You have to do one and then the other. One and then the other. If this was x equals 3, what was in the parentheses? If it came out to 3, what was in here? X minus 3. Okay, now impress me. Those of you that were paying attention before, if it's going to be 1/4, how did that get here? Good, yes. Because they had to add 1 and divide by 4 to get 1/4. Good, excellent. So these last two, we could have solved them by factoring. But they're going to do that in the book too. They're going to say, here, use your graphing calculator to blah, blah, blah. Okay? All righty. 43210 game. How do you feel about the factoring and the calculator combined? You know, you got 2 different things going on here. Okay, that's why I kind of asked you about the factoring earlier. So now some of you are like, okay, this calculator thing, not cool. I'm not liking this. But it's Blinky. How can you not like Blinky?
I like it because you don't have to think of anything.
You don't. It's like you turn your brain off and just let Blinky take care of it.
Blinky always took care of me.
Blinky is my hero.
Blinky is our friend.